All right, I'm going to go through some of the even problems on the study guide. Number 2 and number 4 first. These are when we're adding and subtracting polynomials. Remember, when we're adding and subtracting, if there's a plus or a minus sign in between your two parentheses, you are not using the distributive property from one set of parentheses to the other. It's a lot simpler than that. When there's a plus sign in between the parentheses, really what that means is we want to combine the like terms from both sets. So really you can just get rid of those parentheses when there's a plus sign there, and we're going to combine like terms. So if I take negative 3x squared and negative 2x squared, that makes negative 5x squared. Notice I do not add the exponents. We only add the exponents if we're multiplying terms together. If we're just combining like terms, it's like saying we have negative 3 dogs, negative 2 dogs. It made negative 5 dogs. All right, so then we're going to combine our plus x and our negative 4x together. And when we combine those, we get a negative 3x. And lastly, we're going to combine negative 7 and positive 5 to give us negative 2. So one more thing, when we're combining like terms, make sure not only does it have to have the same variable on the term, but the variable has to have the same exponent to combine it. So we couldn't combine negative 3x squared with x because this one had an exponent of 2 and this one did not. All right, so then number 4, the only thing that's different between number 2 and number 4 is now we have got a subtraction sign there. So that involves one extra step. So when there's a subtraction sign there, that subtraction sign isn't just for the x squared. That means we have to subtract all of those terms. So I like to rewrite it without parentheses. So the first set of parentheses will stay the same. But then we're distributing that negative sign to everything in the second set. So it becomes negative x squared, negative 4x, and a positive 2. So we're just distributing that negative sign to everything in the second set. It's like distributing a negative 1. And now that we've got something like what we had up here, now we're just going to combine our like terms. So we can combine 7x squared with negative x squared, and that gives us 6x squared. We can combine a positive x with a negative 4x, and that gives us negative 3x. And we've got a negative 8 and a positive 2 to give us negative 6, right? All right, the last even problem from our adding and subtracting set was number 6. And this, we've got the same idea going on. Because we have a subtraction sign, we can't just drop the parentheses. We really need to rewrite it with that subtraction sign distributed to everything in the second set. So it becomes a negative 1, a negative 3x, and a positive 9x cubed. Now that we have everything written out, now we can combine our like terms. And when we write polynomials, we write it in standard form, which means we start with the largest exponent first, and then we go down the line. So our largest exponent is 9x cubed. There are no other terms with an x cubed, so we can't combine it with anything else. So we're going to write 9x cubed first. Then we look for an exponent of 2, since we started with an exponent of 3, and that would be negative 6x squared. There is nothing else with an exponent of 2 on the x, so our next term is just going to be negative 6x squared. Then we look at our x's. We have a positive 4x and a negative 3x. So together that makes positive 1x, or just positive x. And then lastly, we have a negative 1. Next, we're going to go through a set of problems that are multiple polynomials in parentheses, but instead of having a plus or a minus sign there, there's nothing there. When there's nothing there, that's multiplication. And when it's multiplication, we use what's called FOIL, or that's basically just the distributive property, but we have to use it more than once. So for number 8, we're going to distribute the x to both terms in the second set of parentheses, and then we're going to distribute the 8 to both sets in the second parentheses. So when we distribute the x times x is x squared. So make sure you put x squared. And then x times negative 5, that's negative 5x. Then we have 8 times x, that's positive 8x. And 8 times negative 5, which is negative 40. So anytime you multiply two x's by each other, you have to add the exponents together. So this is like saying x to the first times x to the first, and that's how we got an x squared there. And then we go back through and we combine like terms that we have. And normally your middle terms will be like terms. So when we combine those, we get a positive 3x. So our final answer is x squared plus 3x minus 40. All right, for number 10, now we're going to distribute the 4x to both the 2x and the negative 3. Then we're going to do the same thing with the negative 9. So 4x times 2x, that's 8x squared. You multiply the coefficients, and then x times x is x squared. 4x times negative 3, 4 times negative 3 is negative 12. And then we have the x. Negative 9 times 2x, negative 9 times 2 is negative 18. Then we have an x. And negative 9 times negative 3 is positive 27. Then we go back through, combine our like terms. So we have negative 12x and negative 18x, which give us negative 30x as our middle term. Then we have an 8x squared in front, positive 27 in the back. Continuing with multiplication, number 12, we have the binomial 5x plus 7 squared. Anytime we square something, we're just multiplying it by itself. So like 5 times 5 is 5 squared, 40 times 40 is 40 squared. So 5x plus 7 squared would be 5x plus 7 times 5x plus 7. This would just be another way of writing it. So you need to write it out as two separate binomials, because if you just take 5x squared and if you just take 7 squared, then you're going to be missing your middle term. So now we need to distribute, and that's how we get our middle term there. So we're going to take 5x times 5x, so 5 times 5 is 25, x times x is x squared. Then we're going to take 5x times 7, so that's 35x. 7 times 5x is 35x. And 7 times 7 is 49. So when we combine our middle terms, we get 25x squared plus 70x plus 49. Number 14 is a little bit different because instead of having a binomial times a binomial, we have a binomial times a trinomial. So what that means is instead of getting 4 separate terms, when you multiply them out, we're actually going to get 6 terms because we have to multiply x times all 3 places, and we have to multiply the 4 times all 3 places. And when you multiply that x, be careful, because whenever you multiply an x times an x squared, we're adding the exponents, so that will become x cubed. So now we're going to have a cubed term in our final answer. So when I take x times 2x squared, we get 2x cubed. X times negative 3x, so we have negative 3, and x times x is x squared. And x times 7, that would be 7x. Now we're going to do the same thing with the 4. So 4 times 2x squared, that just makes 8x squared. 4 times negative 3x makes negative 12x. And 4 times 7 makes 28. All right, now we're going to combine our like terms. This is our only cubed term, so we'll leave it in front. But we have a negative 3x squared and a positive 8x squared, which makes positive 5x squared. We have a positive 7x and a negative 12x, which makes negative 5x. And lastly, we have this positive 28 as our constant. Now we're going to turn to the back side of the study guide where we have all of our factoring problems. And there are lots of different ways to break down a problem. That's basically what factoring is. We're breaking down the original polynomial into as many different parts or factors as we can. And there are lots of ways that we can factor, but the first step you always must do is factor out a GCF. So in number 16, we're going to look at the numbers first. So we've got 12, 24, and 18. So out of those numbers, our greatest common factor would be 6. So we know we can factor out a 6 out of each of those numbers.
Could you please unlock B as in boy?
And they all also have a y, and they all have at least y squared. So in addition to the 6, we're also going to factor out a y squared term, because they at least have a y squared that we can pull out of each term. All right, now, when we're factoring, basically what we're doing is dividing, because factoring is the opposite of the distributive property. And since distributive property we're multiplying, factoring we're dividing. So we're going to be dividing each of these terms by 6y squared. If it helps, go ahead and put them all over 6y squared. So when we divide, our coefficients, we're actually going to divide the numbers. So 12 divided by 6 is 2. But with exponents, we remember from our exponent rules from the last chapter, we subtract exponents. So y to the 6th divided by y squared is y to the 4th. So then if I were to multiply this back out, I would have 6 times 2, which is 12, and y squared times y to the 4th, which is y to the 6th. Then 24 divided by 6 is 4. We started with y to the 4th, but we factored out 2y, so we have y squared left. Then we take negative 24 divided by 6. Started with y cubed, but took out 2, so we have y. And negative 18 divided by 6 is negative 3, but we factored out both of those y squared, so we're not left with any y's. Now, if you did factor out your greatest common factor, the terms that are left in the parentheses should not have a common factor any longer. So if you look at these numbers, make sure they don't have a common factor, and make sure they can't all have a y, or else you didn't factor out enough y's. Finally, make sure your greatest common factor is always in front. We always will put our greatest common factor right there to let us know that, hey, this is the greatest common factor. That's how we did that. Now, the other factoring that we've done so far is we've factored trinomials, and then we factored binomials if they are a difference of squares problem. But we do not have a trinomial here, so we're just going to call it quits on this one. Continuing with factoring, now we're going to move into factoring trinomials. And again, first step, always look for a GCF. Now, if your first term does not have a coefficient, then there's probably not going to be a GCF unless all of your terms had an x. Then we would factor out an x first. But that's not the case here. So when there's not a coefficient and there's no GCF, then we hit the factoring jackpot. That means it's going to be an easy peasy problem. So you set up your two parentheses, you write x and x. Now we have to do our signs. A plus sign in the back means they're going to be the same sign, so either plus plus or minus minus. In this case, they're going to be minus minus. So now we're looking for two numbers that multiply to 14 and add to 9. And those two numbers are 2 and 7. And then we're done. Okay, so number 20, moving on. We do not have a greatest common factor. We do not have a coefficient in front, so we hit the factoring jackpot. We set up our two parentheses. Whenever there's a subtraction sign in the back, that means you're always going to have one of each, no matter what that sign is. If there's a minus in the back, you need a positive and a negative, because a positive times a negative number will give you this negative number in back. So now we're looking for two numbers that multiply to negative 8 and add to negative 7. And those two numbers are positive 1 and negative 8. Now we can't flip-flop those. It can't be positive 8 and negative 1, or else we would get a positive 7 as our middle term, and it needs to be negative 7. But you can rewrite this to say x minus 8 and x plus 1. That's okay. It's okay to flip your two binomials as long as the plus sign and the minus sign are with the correct numbers. All right? Moving on to number 22. This one's a little bit different because we do have a coefficient in front. Always check for a greatest common factor, and in this case we do have one. All of these are divisible by 2, so before we do anything else, we have to factor out that 2. If there is a greatest common factor and we do not factor that out first, then our answer is going to be incorrect. You have to factor out a greatest common factor if there is one. So when we factor out that 2, remember it's the backwards distributive property. So we end up with x squared plus 2x minus 8 in our parentheses. We do need this greatest common factor in front, especially in our final answer. And now we hit the factoring jackpot again because there's no longer a coefficient in front of our x squared term. So we don't even have to use the bottoms up method. We can just make our two parentheses with x and x. Minus in the back means we need one of each sign. We're looking for two numbers that multiply to negative 8 and add to positive 2. And that would be a positive 4 and a negative 2. Got to keep our GCF out in front. And this would be our final answer.